kind of off to the side here, that cosine of negative x is really cosine of x.
Mhm.
Uh, how would you know that? You would memorize, or you'd remember the graph. The graph is symmetric about the y-axis.
Mhm.
It's even. That's why it's kind of weird that it's built in. So this becomes negative x cosine of x, like that, right?
Okay.
That's
Because
kind of
it's
like,
and
what?
because it's the negative x, it's an oh, I mean, never mind, ignore that, sorry.
Well, this is pretty challenging because like cosine of negative, like what we're using is the fact that it's an even function, but we're asking about the whole function here. So
Oh, so it would be odd then because it has the negative x
we'll get to
or
that. We'll get to that. So the first thing is what's here. This is kind of your first checkpoint or your gate, as you'll learn in project management. Is is this exactly the same as the original?
no.
It is not. So it is not even.
Okay.
Which does not mean it's odd. It just means that it is not even. It's not like numbers that are even. Okay. So the next thing you do is you factor out a -1. So you get -1 x cosine of x. And then you ask yourself the same thing. The part inside parentheses, is this exactly the same as the original?
Yes.
It is. Yes, that means it's odd.
Okay.
So the sequence is always you first check for even. If it's not even, you check for odd. If it's not odd, then it's neither.
Okay.
Questions, thoughts on that?
I don't think so. Is it okay though if we do B as well?
Of course, yeah, you are the
Is
customer. You dictate what we do, work on here. I'm the learning guide, so I'm just here to sort of suggest and things, help things. But
yeah,
yeah,
I need all the redundancy I can get.
right. And I'm happy to make up problems like these or give you ones that are in the same, you know, classification here. So yeah, so part B is, do I have a snip ready? I do not. All right. Part
So
B is the same thing here. We're gonna first put -x in for x. Okay. And this is where you have to know, well, what is cosecant in terms of sine and cosine? Well, it's 1 over sine of -x. And then kind of off to the side here, you're supposed to know that sine of -x. And when I say that, what I mean is like, as a student in this class, this is information that you're expected to know. I'm never
Mhm.
saying you, Cassie, you need to know this. Like, no, it's like you decide. Um, this is this is this is because it's an odd function. Sine is an odd function.
Mhm.
Okay, so that means that this becomes 1 over negative sine of x. You can bring the negative up, which is kind of standard to
Mhm.
do, or leave it out in front. And then you can use the reciprocal property to say, okay, this is really negative cosecant x. And this is where that first gate checkpoint is you say, well, is this the same as the original?
It is not.
That's right. So it's not even. So then you factor out a -1. And then you ask yourself the same thing, is the part inside parentheses, is this the same as the original?
Yes.
Yes, so it's odd.
Okay. And then what about for arctangent? Because I don't think there's an identity for that.
Um, yeah, good question. So this is kind of an odd oddity. I know you sent over the solutions. Does it just give the answer?
Yeah, it doesn't tell you how to
Okay.
do it.
So yeah, so the arctangent has this graph here
Hmm.
like this. And so you can visually see that yes, it is odd.
Okay, I
Okay.
see.
But that's not the right way to do it. So let's
Oh.
the whenever you see a tan inverse, you typically use a substitution of theta equal arctangent of x. The tangent of theta, pick the tangent of both sides equals x over 1. And so
Hmm.
you can draw a triangle here. Uh, 1 plus x squared. Okay. So um, where do we want to go from here? So the tangent, how do we want to do this? Yeah, see, I'm sort of like, well, the graph is not enough to prove it, but what else would you guys uh, do? So you would actually look at this here, and because you basically made a change of variable here,
Hmm.
and so you would check, well, what is minus theta? So tangent of minus theta, and that's
Hmm.
really sine of minus theta over cosine of minus theta. And so that's where you can either um, go back to your knowledge of sine and cosine, so that the top one is minus sine theta and the bottom one is cosine of theta because it's odd and it's even. And then
Hmm.
you ask yourself, well, is this the same as the original? This is minus tangent theta, by the way. The answer is no, so it's not even. And then when you
And
factor out the negative, is the
it's not
part
odd.
inside.
So
Well,
it's
this is no, this is the original. The original is tangent of theta.
oh, my bad. Forgot about
So
that.
yes, it's odd. Uh, Um, another way to do it is, which is okay. We know that tangent of theta looks like this graph like this. It's odd. So the inverse is also odd. And the same thing applies to sine being odd. I don't know if you're allowed to use that. So I'm sort of guessing, what to do. I don't really know what they want.
Yeah, I'm not 100% sure how she wants us to do this either.
Okay. Do you know if there's office hours tomorrow?
Uh, I don't think so, or not any that would, because like literally this week, like I've got like test after test after test.
Okay.
So
Yeah, it's always good to, just for future semesters, know where those office hours, go in, talk to them. Then they know you're a human. They don't think of you as a number. Even good to tell them your situation. All
okay,
right. So yeah, they're all odd is the long of it, short of it.
and then sorry, I'm looking real quick. Oh, and then I wanted to look at number 9.
Okay. I think we did the other nine. So we can do A or we can do them both again.
Yeah, just as a quick review.
Yeah. So this one, there's it's normally you let theta equal the thing inside parentheses, but because there's a 2 there, we're going to do a 2 theta equals 2 sine inverse of y. And that's just something you're going to have to go with without a lot of explanation here for the moment.
Oh, and then would you do the double angle identity?
Yeah, so this becomes cosine of 2 theta, which we're going to use one of those double angle formulas, which you have to memorize. I just go look them up, but you have to remember them. It's kind of a rite of passage in these courses. So maybe we'll do 1 minus sine squared theta, but there's a bunch of them that you can use. There's 3 that you could use. So that's just one of many. So the reason you do this substitution is that the 2's cancel and you get theta equals sine inverse of y. You take the sine of both sides. Sine of theta equals y, or y over 1. You draw your triangle, always in the first quadrant. That's y and 1. And another reason to use sine squared, 1 minus sine squared for the double angle formula is that you don't have to even find the third side. But if you did, it's this right here.
Mhm.
If you needed to, that's using Pythagorean theorem, a squared plus b squared equals c squared. You will use that again in calculus too. This trig substitution stuff. All right, so then coming down here, like we said, it's really cosine of 2 theta, which is really 1 minus sine squared theta, which is 1 minus y squared. Sine is y, so that's your answer.
Okay.
What does that mean? I don't know. Doesn't mean anything. Do you want us to do part B?
Sure.
Okay. Right. Like it, and it should make this comment that it's really easy to change these two half angle formulas, like if this was 1/2, something like that. But because it's a 2, it's a double angle. So you let theta equal, um, well, normally you would let theta equal like whatever's in sine there, but because there's a 2, you let 2 theta equal 2 cotangent, because then becomes secant of 2 theta.
Mhm.
So then the theta is just the cotangent inverse of x. Take the cotangent of both sides. You draw that right triangle in the first quadrant, the reference triangle there. So it's this, and then you find the third side using Pythagorean theorem, 1 squared plus x squared for the third side. Any questions on that before we proceed?
I think I'm good.
All right, so secant 2 theta is 1 over cosine of 2 theta. And so that, again, we got another double angle formula that ends up being 1 over 1 minus sine squared theta. And so, or, any of the other ones you want to use. So sine of theta, we have to somewhere find, okay, sine of theta is opposite over hypotenuse, 1 over square root 1 plus x squared. So this becomes 1 over 1 minus 1 over square root 1 plus x squared all squared. And now it's just an algebra problem. It's just a nasty, horrible, simplifying thing. Um, you make a common denominator on the bottom here of 1 plus x squared. And so it becomes on the top 1 plus x squared minus the 1. You can see the 1's cancel. You're left with the x squared. 1 over x squared over 1 plus x squared. And so you'll remember that if you have like a 1 over an a over b, it becomes b over a. So you just flip it, 1 plus x squared over x squared. And there you have it.
Um,
So it's almost as much work to like do this part as it is the like original part of the problem. Like the trig is over, and
mhm.
you'll find calculus is like that. There's like one line of calculus and the rest is like pre-calculus, college algebra, trig stuff.
Okay. And then I can we skip all the way to 21.
Sure. Take a look. $21. Okay. A graph really helps. Are you allowed to use a calculator for this?
I believe so. Well,
Okay.
even if she says no, I'm gonna still do it.
Yeah, no, that's good. That's a good strategy. It's better to, beg forgiveness than ask permission. Oh, I didn't know, let's use you already. So 1.3 to the power of x looks like this,
Mhm.
but the -2 flips it.
Oh yeah.
So if you can graph it, you'll get this right away, but you don't need it to graph, or you don't need it to answer this question. It's good to have a visual.
Hmm.
It's really good to have a visual. Okay, domain. There are no restrictions. So this is all real numbers.
Hmm.
The range is the min to the max. If you get the wrong shape of the graph, you won't know. The range here is -infinity to 0. You can think of it as min to max, bottom to top, something like that.
Okay.
Now, end behavior as x goes to infinity. So this means in words, to the right forever. And then they're asking about, well, what does f of x do? What does the y value do? And you want to think of it in terms of rising or falling. So over here, is it rising or is it falling?
It is falling.
Falling. So that's -infinity. Rising is infinity. So you got to
Okay.
choose the right one. And I like those words. I think they're more meaningful than just, down or up. Uh, kind of
Mhm.
switched, transitioned from, different words over the years that they mean more to students, mean more to me.
And then for what is it? And then for B, would it be the same except for the range would be different because hold on, let me graph it real quick. Because there would be a there's a +4. Sorry, my
Yes,
window.
so e to the minus x looks like this,
Mm-hmm.
and then +4 is this graph. So we didn't say it in the previous problem, but in exponential growth or decay, which is what you have potentially here, the this is called the vertical asymptote, and
Mm-hmm.
the range, depending on your problem, it's either -infinity to the vertical asymptote, or it's the vertical asymptote to infinity. Those are the two possibilities for the range.
Okay.
It depends whether it's approaching it or approaching it, from the bottom or the top. So the graph's really important. And
Sorry, my dog just came running in and was like, hello.
yeah,
So first.
yeah. Make sure you're comfortable either, if you got questions, I got a virtual TID3 I can show you if you're ever unsure how to graph stuff. Uh, you will want to be more knowledgeable of this for future courses.
Hmm.
So, okay. So domain, it's still all real numbers.
Is there any situation where it would be restricted or is it just always like all real
Well,
numbers?
that's always a starting point. So yeah, of course, there's restrictions. So root functions are restricted, rationals are restricted.
Mhm.
Um, uh, certain trig functions are restricted. Um, yeah, this exam isn't really emphasizing that. If I don't know if you took college algebra at the university or not, um, but their college algebra class is a lot of questions like 1 over x squared minus 4, and you got to figure out the domain of that.
Okay.
but it does not seem to be emphasized here. Now, this one's a little bit different with its end behavior as x goes to infinity, again, to the right forever. So
Mhm.
in this case, f of x does approach a number. It approaches always the horizontal. Sorry, I'm so sorry. This is a horizontal asymptote, not a vertical asymptote. Very tired, so that's why that is the case. It always approaches the horizontal asymptote, typically.
Anton, watch the dog. Anton, watch the dog. You're in charge of her. Sorry. Ay, ay, ay. Little brothers be little brothering right now. Anyways.
Um, so in the previous problem, the graph did kind of go away from the asymptote. It could go towards it. And it's a
Okay.
horizontal asymptote, not a vertical asymptote. I apologize. I didn't mean to say that. Truthfully, I'm a little tired, but it's the
Okay.
horizontal. It really comes down to knowing what the graph looks like. Um,
Hmm.
so good luck.
Okay. And then, I'm trying to think. What is the next one? Sorry, I wrote them all down, so I'm like switching back and forth. Hmm. Where did it go? Oh, can we do 27 real quick? I kept making like some dumb mistake and I can't figure out what the dumb mistake is.
Okay, yeah, let's take a look. Simplify the expression completely. Okay.
Like it's very simple, but yet it's like I keep somehow messing it up.
All right. All right. So this becomes 5 squared times 5 to the log base 5 of x. So that
Mhm.
did I send? I shouldn't even ask. I'll just put it in the notes here. So there's a reference sheet for exponents that I'll send you. Um, the one reason here is that it's the undoing of like x to the n times x to the m equals x to the n plus m.
Mhm.
And so 5 squared, you're supposed to know what that is. That's 25.
Mhm.
And then there's another property which says log b to the log base b of x becomes just the thing that you're taking the log of. So that becomes 25. 25x.
Oh, I see. Okay.
Yeah. Now, if you're really stuck on a test and like this is one of the options, you can graph that to see if they're the same. You might graph it just to see if it looks kind of like, is it a line? Is it quadratic? Like, what is it? That might help. Um,
Mhm.
yeah, that's that's a situation there to help. But I don't recommend that. I recommend trying to learn the rules, but limited time.
Mhm. Okay. Oh, and then can we do number 30 just real quick?
Sure. Why am I losing my place? There it is, 30. Right, log base a of x equals -4. Find the value of this thing on the right. So really, they're just telling you, hey, expand this, expand, and then later on, use this.
Oh, that's what I kept like trying to like plug it in and but there's parentheses. I don't know what my brain was doing.
Well, I mean, that's where I'm the guide here. You got it. Like, there's a lot of questions in this test, the way they're written, where it's mid-direction. You want to look at the end and then go back and use the given. Uh,
Okay.
so the first thing is that you're separating this as they call it product to sum formula. for logarithms. Product inside parentheses becomes a sum.
Sorry,
Is
can
that
you say that
okay?
one more? Sorry, I was like, I like yawned and I was like, what?
Product, the sum. So there's a product multiplication inside the parentheses. That becomes the sum here in the middle. That's how
Oh,
some students remember that.
okay. So
All right.
it's just as simple as just plugging in -4.
Not yet, not yet, not yet, not
Oh,
yet. This over here on the left is 1.
hmm.
There's a,
Because yeah, because the A's cancel
yeah,
out.
well, it's a little bit more than that, but I'll let that slide. Um, yeah, so the 3 comes out in front. That's another property, log base b of x to the n. The exponent comes out in front. So you've got right now 1 plus 3 times log base a of x. That's when you substitute in for -4. 1 plus 3 times -4 becomes -11.
Okay.
Would you like one like this to try?
Sure.
Okay. Do you have all this down, or do you have any questions before I give you one?
I'm good. I'm ready to try one.
All right, I'm gonna make it slightly different because I don't think it helps to just give you like exactly the same. Um, but it'll be the kind of the same type here. All right, so here you go. Here's your problem. And feel free to ask questions if you're unsure how to proceed.
Is it -1?
Let's take a look. So it ends up simplifying to 3 log base b of b plus 2 log base b of x. 3 times 1 plus 2 times -2 ends up being -1. Good. All right. What else would you like us to look at?
And then, mm, okay, and then can we just like skip like all the way to like 37 and just like work on like, because I guarantee like a crap ton of this is going to be on the test.
Sure. Yeah. Yeah. Um, so G, well, I guess I'll just, do you want to just go through an order? Do you want me to pick and choose ones that I think might be more relevant?
Um, I guess just go in order.
Okay.
Okay, so
So
for A,
they're, okay, go ahead. What were you going to say?
oh, for A, since they all have the same base, wouldn't they cancel out? And wouldn't you just be left with the y -1 plus the y plus, wait, hold up.
Yeah,
Oh,
that's
wait,
that. We don't want to do that. Uh,
no,
you're,
I thought this, oh
you
my
want to
gosh.
get it. This is, I call these type, and I don't know which number this is, but it's a type where you want to get it to log. You were on the right track. You want to get it to the log of something equals the log of something,
Hmm.
which means you have to condense these two on the left. So a sum goes to what? We just said it in the previous problem. A product goes to a sum, so a sum goes to a
Product.
product. So it becomes y minus 1, y plus 1 equals log of 8. So now do you have this type?
Hmm.
You seem a little questionable there. Do you agree or not? Do you need more explanation?
Oh no, it's the same. It's the same kind because
Okay,
you just
okay.
combine them.
Right. So what reason I'm doing this is you're gonna go into more and more difficult courses, and this is what you have to be able to do. You have to recognize, oh, this is this type of problem. Okay. There's
Hmm.
another type where it's log of something equals a number. That is not this problem. That's number C or D.
Okay.
Yeah, or F. And the point is you have to be able to recognize like this type. So you know what to do. So yes, now you can, and it's not that they cancel, there's an inverse operation, but you can effectively say the inside part equals the inside part.
Okay.
Like there's another line of work here that is not necessary, but pure mathematicians would be very angry if they heard these words. I don't care. I'm fine with this, but you should know there's a little bit of, there's another step here. So
Mhm.
um, you have to be able to quickly FOIL this,
So just be 3.
yeah, plus or minus 3. And then you have to check for extraneous solutions. And the reason is that what you did here is you solved a quadratic problem, which has a domain of all real numbers. So you cannot apply the solution to all real numbers to a restricted domain like you have up here. So that's
Okay.
the reasoning behind it. You need to know that you go back and check. Now, this isn't high school where you just cross out the negative one. In college, they will just as likely give you the exception than the rule. So you just check and see if it's okay or not. Um, does that make sense, like what I'm saying, or does that sound really foreign to you?
No, it makes sense.
So log of 3 minus 1 plus log of 3 plus 1, that's okay. The thing inside parentheses here has to be greater than 0. That's fine.
Hmm. Okay.
Log of minus 3 minus 1 is minus 4. That's bad.
Okay,
Okay, so
I
you
see.
so, so you say, oh, that one's out. If it's multiple choice, you'll see 3, -3, plus or minus 3, no solution, all the options. So you got to know this. And you got to know why, more importantly.
Hmm.
Okay, so H, if we're kind of using this idea of type, H is H is just like this type. Okay, so we should try this one next. So we need to get into this form of log base 7 of something equals log base 7 of something. So how do you combine the two logs on the left?
So it'd just be log 7 5x plus 2 over x.
Very good. And that equals log base 7 of 12. You set the parts inside parentheses equal to each other, and you solve from there. Do you want us to solve this, or do you feel like you've got it?
Okay, it's 2 over 7 equals x.
Okay.
Well, I guess technically plus or minus.
Nope. Nope.
Oh wait, hold up. Oh wait, no, it
The re
can't be.
It is not. It's not a quadratic. So you said 2/7?
Yeah.
Okay. So you should check it, but you know, I would only do that if I had time at the end. When you get one
Okay.
answer, you're usually okay, as a general rule.
Okay.
All right. So the next style of problem here, we're gonna do F first. There is a order to this. So this type of problem, this type is we're going to get it down to log of something equals a number. So this becomes log of 8 times h minus 15 equals 2 when you condense the logs. Is that clear? Sum becomes a product, product
Mm-hmm.
becomes a sum. Okay. What is the base of log that's not written when it's not written here? Do you remember that from class?
Yeah, 10.
10. So there's this step now to undo the logarithm where you apply the same base of the logarithm as the exponent base to both sides of the equation. Have you seen that before?
Mm-hmm.
So it does undo the logarithm. And don't forget to, it's so easy to do this, to not multiply this. And they sometimes make problems where it works with 2 or 10 to the 2. They're very tricky. And so you bring the 100 back over, and then you have to be able to factor this. How's your factoring?
I'd say pretty good. So it
Okay,
would
so
just,
you're good.
so it'd be negative, um, wait, yeah, negative 20, h minus, h minus 20, and then h plus 5.
Okay. So if you do this, you will get only half credit because one of these is probably extraneous.
Mm-hmm. And then you just plug it back in.
Yes. Try, and you're looking for the one that makes, and you got to go back to the original. That's the other thing. Like if you check it at anything but the original, that's not good. Um,
Oh.
so you have to make sure you go back to the original. And so it does, which one is,
It would have to be 20 because you can't have the negative 5 in the logarithm.
that's right. So that one's out. All right. Very good.
Mhm.
So now let's look at number letter C. C is a lot like what we just did, except it's more basic. Um, it's already been condensed, so you don't have to do anything. Um, do you remember how to undo ln?
Yeah, it's with E.
Yeah, so it's e to both sides. So this time it becomes 7w plus 3 equals e to the 11th. E to the 11th is a number. It's not, it's not a friendly number. You maybe not comfortable with it, but it's a number. It's not a bad thing. And you're solving for w. Uh, this is like a literal equation where when you solve, you don't get a nice result. You just get kind of an ugly expression,
Mm-hmm.
and you have to be okay with that.
Okay.
Right. So we got time. Yeah, we're gonna do G next. G is actually a lot like the one we just did. It's got like a little added wrinkle to it.
Mm-hmm.
So how do you undo ln? Well, it's e.
Mm-hmm.
What is e to the 0? What
Mm,
is
0.
anything to the 0? Nope. What is anything to 0 power?
Oh, oh, I forgot. It's an exponent. 1.
1. And then you do the same thing. You're like, all right, I'm going to undo it again.
Mm-hmm.
So x equals e to the 1. So I think there's like on the test, I think I saw one time, there's a question like natural log of natural log of natural log of x, like this. And the answer ended up being like x equals e to the e, which is the next iteration of this. Um,
Okay.
you could look at that later if you want. Can't sleep, you want something. All right. So D is a more complicated version of C and F. Do you want us to do D, or do you want us to move on to E and B?
Mm, I'd say let's do it because knowing my luck, that'd be the one on the test.
Okay. Glass is half empty, not half full. Yeah. So, uh, boy, this is I don't even know how you know this. You have to know to bring this two to the other side of the equation.
Okay.
You're like, why would you ever do that?
Oh, is it like some twisted factoring thing?
This is
Or what?
higher order factoring with substitution. So you're going to want to start using U for your substitutions. You're going to do that a lot in calculus and other courses. So when you square it, you square both. So you get 2u squared minus 3u minus 2 equals 0. It's best to use a guess and check approach rather than I don't even know what they call it anymore, where you diamond method or something. Like when there's only one way to get 2, you should use guess and check.
Okay.
Whenever so that's my recommendation. You do whatever you want, of course, but this will help. So the mistake here is you solve for u, and guess what? In multiple choice, these answers will be there.
Mm-hmm.
Seriously, they'll put those two answers there, and you think you got it, and you'll walk out and like, why did I get a C on my test? So you have to remember to back substitute. You'll do that in other courses, back substitute. So log base 5 of t equals -1/2. Log base 5 of t equals 2. All right. And then just like we've been doing, how do you undo the base of 5? 5 on each side.
Oh, I see.
So t equals 5 to the -1/2 power, which if you haven't done this in a while, is 1 over 5 to the 1/2 power, 1 over the square root of 5. They might even ask you to rationalize it, square root of 5, square root of 5. So you get
Mm-hmm.
square root of 5 over 5. Any of these could appear on the test, but this is also correct as is. And on the right here, 5 squared is 25. All right.
Okay. I see.
So B is horrible. Same with E. So you can't make the base the same, so you have to undo them with ln.
Okay.
So you get n times natural log of E, which ends up being 1. It's nice. N plus 2 times natural log of 3. And so from here, this natural log of 3 is like e to the 11th. It's just an unfriendly number. But the more math you do, the more you're just gonna have to be okay with things that don't look, visually appealing. You collect the n terms on one side of the equation, so you move it left. Factor out an n. And then you divide. So your final answer is 2 natural log of 3 over 1 minus natural log of 3. They could do this where the answer, sorry, that's not right. That 2 goes in with the 3, so you might see it as natural log of 9. You might see that, especially on a multiple choice. So you have to know all the different ways to present the answer.
Okay.
All right. Okay, we're going to stop there for today.